No.
Why does this feel so
Yoshida,
dusty?
you're making it easy for me to pick captains.
Oh, oh,
Or not pick,
oh.
as the case may be. Okay, the last method of proof we're going to cover is proof by mathematical induction. I'm going to do number 12 for you.
Oh, induction.
Finally.
Electricity.
Okay, what happens when you add the first positive odd number?
You get one.
You get 1. What happens when you add the first 2?
4.
You get 4. What happens when you add the first 3?
9. Ooh, I see.
I see a pattern.
I see a pattern.
And squared.
What happens if you add the first 4?
75.
16.
No. You get 16.
Wait, it's a
That's
7.
7. I'm going, that doesn't add up to 16. Hey! Do somebody. This is 1 squared. This is 2 squared. This is 3 squared. This is 4 squared. So, just because it works for these first 4 cases, can you assume they're going to work for all?
Yeah.
No, you can't. It has to be mathematically proven. So how do you prove that a statement works for all positive integers?
Suppose.
You use proof by mathematical induction. So this is what we want to prove. 1 plus 3 plus 5 plus dot dot dot. What would be the nth positive odd number?
2n plus 1.
2n plus 1 or 2n minus 1?
2n plus 1.
Plus 3.
Let's just do minus 1 for
2n
the.
plus
No,
6.
no, you have, no, there's no,
There's no difference.
there's no difference, but yeah, it has to be correct.
Minus
See, this is the first
Because when you add
positive odd, that's the second, the third, so what would the
Oh,
nth one
minus
be?
minus 1.
2n minus 1. Come on, this is
Oh, yeah,
sequences,
yeah,
this is
yeah.
like the explicit formula for the odd numbers, oh my goodness. So we want to prove that this statement works for all positive integers.
You assume it works for k.
Okay, so this is how mathematical induction works. Okay, why don't we call this statement P of n?
Assume the statement is true.
Okay.
For all.
So the first thing you got to do in your proof is show that P of 1 is true.
Base case.
Yeah, the base case. And then you have to show that if the statement is true for any positive integer, then it will be true for the next positive integer.
All we know.
Exactly. So if you can prove this, do you see how you have to have both of them?
Yes.
So if you can prove that if this statement is true for any integer, it's going to be true for the next integer, then
It's impossible.
once you prove that it works for 1, then this tells you it works for 2.
Yeah.
But then now that we know 2 is true, then it's going to work for 3. It works for 3, it works for 4. 4 then 5, 5 then 6, 6 then 7, dot dot dot. Therefore it's true for all positive integers.
Yes.
Okay, so here we go.
I agree with
So
that.
this is proof by mathematical induction. That it's a 2-step process. Don't forget about this first one now. Just because you prove this, you haven't done anything yet. You have to show that it works for 1. So let's first prove that P of 1 is true. Well, is 1 equal to 1 squared?
Yes.
Yes! That's the easy one. Now we have to show that P of k implies P of k plus 1. In other words, if this statement is true, then this one will be true.
Yes.
Write out the second statement.
Okay, so this is the space we're going to use to put all our work in. Now, what is P of k? This is the statement P of n. What would P of k be?
Plug k in.
1 plus 3 plus 5 plus dot 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 plus 2k minus 1 equals k squared. Now, we don't know if it's true, but we're trying to prove if it's true, then this one will be true. So what you might want to do is you might want to actually write in this statement right here, and then fill in the steps over here. So how would you write this statement here? 1 plus 3 plus 5 plus dot 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 plus 2k minus 1 plus,
2k plus.
what would be the next one?
2k.
What would be like the next one?
2k plus.
2k plus 1.
2k plus 1, because the pattern is you keep adding 2 every time, right? And that's going to equal to
K plus 1 squared.
k plus 1 squared. So basically, you're simply substituting k plus 1 for k, or n, if that's the way you want it. So
You're
now, you gotta ask yourself, if this statement is true, how do I show this one here is true?
Immediately, you just add the two.
Yeah,
sides.
so this is a really easy one.
Subtract.
So maybe we might have to do another one. So, look at this.
Add the
What do I have to add to both sides of this equation to get this right
2k
here?
plus 1.
Add 2k plus 1 to both sides. Is that a legal step in mathematics? Yes, you can always add the same amount to both sides. So I'm going to add 2k plus 1 to both sides of this equation.
Hey, look at the
Hey,
other side.
it's
somebody.
And then, can I say that is the same thing as that?
Yeah.
Yep, so there you go.
I see that.
See, so this is like really simple. So we just proved in this step here that if it works for any integer, then it's gonna work for the next one. But since it works for 1, then it works for 2, which means it works for 3, then 4, then 5, then 6, then 7, dot, dot, dot. Therefore, it works for all positive integers.
What's your part?
Yeah.
Okay, can I do this one?
So, what?
Can I just like plug in?
You can do anything you want.
Yeah, you can do that.
Everything in this class is optional.
It's fine.
I just showed you, so that's why you weren't listening. You like being scolded on video. Roy, song,
Song roll.
class of 2019. Okay, you know what, let's do a harder one, that one's too easy.
First
Now
students
look at those interesting formulas, look at number 13. What is number 13? Somebody tell me what that formula is. So no, let me call on people.
Oh,
So-
Oh, easy, geometry.
Yeah,
Shh,
so-
no!
Okay, I was actually gonna say that.
Oh, really?
Sorry
Really?
about that.
Okay, no, so what is number 13? That is what, what's the formula for?
It was like 13.
Number 13, tell me what that formula is.
The sum of geometric sequence.
The first n terms, or infinite.
The first and end.
Okay, and then 14, remember the sum of squares?
Yeah.
And then sum of cubes? And then now look at the number theory ones. Number 16, prove that 3 divides n cubed plus 2n.
That
It
is
does.
a good thing.
Yeah, well, that's what you have to prove.
Oh.
You
And
can
then number
use modular
17,
arithmetic.
prove that 3 divides 4 to the n minus 1.
That does.
No, you might say, oh, duh, but it has to be proven. You know what? Okay,
Let's do
okay, pick
16.
one. You want to do 14 or 15? I'll do one more for you.
Can we do 16, please? That one's good. I already did it, I just.
Yeah, no,
Yeah, we're
these guys. Okay, Tran, 14 or 15, pick one.
50.
Wrong! No, we'll do that one.
What's to say no?
That's funny. I forget which one you said, 15?
Yeah.
Oh, because you think the bigger the number, the harder the problem is?
No, because there's a square in there.
What? 1 cubed plus 2 cubed plus 3.
Very true.
Come on, this is for PCH plus n cubed is equal to n times n plus 1 all over 2 quantity
Yeah, we should
squared.
all go to PCH classes and give a talk.
Let's do Christmas
How
carols.
important PCH is.
I gave them the talk.
No one
Remember,
else.
yes, one of my former students came in, they just don't, you don't realize how important PCH is until you get to upper level
Until
mathematics.
you search.
Yeah,
Can we do Christmas caroling later this week?
no,
He's doing
we're
it
not
tomorrow.
gonna Christmas carol.
But
You said he's
We'll
doing
carol in this room.
Oh, in this room.
Okay. Down.
But maybe like in
Down the
PCA.
hallway.
Okay, so number 15, no, we are not going to other rooms.
Aw, but
Okay,
what's
Okay,
the
here is
allowance?
P of n. What's the first step? What should I do first? Solve. What's the first step in a mathematical induction proof? Wait, let me look at my notes.
P of 1 is true.
Show that P of 1 is true. Well, let's see. If I plug in 1 for n, is 1 cubed equal to 1 times 1 plus 1 all over 2 quantity squared?
Yes.
Yes. Wait, some of you are still thinking about it? Okay, now the meat of the proof. We have to show that if this statement is true for any integer, then it is true for the next one. So, the statement P of k, simply plug in k for n. It's, come on, my dog can do this. See?
Yes.
Okay, now P of k plus 1, now you can plug in k plus 1 for n. 1 cubed plus 2 cubed. Now, in my experience, instead of just plugging in k plus 1 there and getting k plus 1 cubed, you know what is a lot simpler? show that and the previous one. What would the previous one be? K cubed. Equals k plus 1, plug in k plus 1 there, so you get k plus 2, all over 2 quantity squared. So all you have to do is fill in the steps, but by doing this, it's pretty obvious what you have to do, right? What do I have to add to both sides of this equation to get this?
1, 3, 3, 1.
No, k plus 1 cubed.
Oh yeah.
See, that's why if you do that, it's pretty obvious what you need to do. So, what we're gonna do is we're gonna add k plus 1 cubed to both sides. Basically, this is just algebra. Algebra never hurt no one.
It hurts.
You heard my grade.
Really?
My
Yes.
GPA.
Okay, so one, you know when we used to actually learn this at PCH?
Wow,
Like
that's
25 years ago.
Wow, that's insane.
But you know what happened, right? Video games.
Do you guys have video games back then?
Yeah, I had to do. Even when I was in high school, I had video games. Pong. You ever heard of Pong?
That doesn't count.
That's a video game. We used to put in a quarter to play Pong.
But it's like 2 moving
Okay,
bars.
that's all it is.
Oh.
Okay, you had a paddle on this side, so you can move the paddle up and down.
Oh yeah, yeah.
And then you got a paddle on this side, so this is you and that's your friend. And then you have a ball that's going. So-
Mr. Park, I have a really cool induction.
So if the thing goes past you, then you lose the point. Yes. So here's a ball coming like this. It bounces off there, and then you gotta move this thing up here to hit it, and then it shoots off.
That's like
And
air
so you
hockey.
gotta move this paddle here so that you can hit it, and then it.
That's
And it
like air hockey.
Find the angle
Yeah.
of depression.
yeah. So the angle of incidence equals the angle of reflection.
Yeah.
Optics.
Why are we even talking about that? So we used to
Video
pay
games.
25 cents to play that.
Rip off.
Oh,
And 25
That's
cents
a
was
lot
like
of
what?
dollars.
Worth like
That's
a
a
burger
lot
or
of
something?
money.
Yeah, 25 cents when I was in high school was a McDonald's hamburger.
Wow.
Wow.
Because we used to pay 25 cents plus 1 cent tax.
Wow.
And French fries was 25 cents.
And taxes.
So you could get a hamburger and fries for 52 cents
Ooh.
at McDonald's. Yoshida.
Can we try this induction problem after, like as a class after this? Because it's a nice induction. And it's like doable.
Alright. Because the more I do, the less you have to do, right? No, I'm not going to do anything, Mr. Park. You can't make me. Who am I?
Try.
Yay! You got it.
No, I'm wrapped.
Okay, so see how the left side of the equation is all set already. You just gotta show this is equal to that. But that's pretty easy, right? Just make a least common denominator. When you add fractions, you make, okay, what is the least common denominator for these two fractions? Song?
4.
Okay, 4. So what goes on the top? K squared times k plus 1 squared plus 4 times k plus 1 cubed. Oh, we might have needed more space. Okay, now what can I do to get from here to here? Because the left side is all set. You know, before, I used to let the students go like this. That's kind of weak, but.
Factor k plus 1.
Or they wanted to use the ditto mark.
Ditto.
Okay, whatever. Okay, how can I transform this into this? Well, what can be factored? Look at the numerator. What can be factored out? If I factor out a k plus 1 quantity squared, what's left?
K squared.
K squared plus 4k
Plus
plus 4.
somebody.
Use somebody. Okay, you know what? Now we need to go down to the next line. Okay, so pretend this is the next line. You're gonna have k plus 1 squared times k plus 2 squared all over 4. And then the line after that gonna be k plus 1 times. We don't even need the next line. That's the next line, right?
Box that.
So QED. Quad erat demonstrandum.
Quite easily done.
Yeah, exactly. Okay, Yoshida wants to do number 16 or 17?
Can we do the problem?
Which one?
16.
Oh, 16.
Okay, let's do 16 and then
16.
playing games and going
Wait,
home.
can we do the special problem, Mr. Brown?
The what?
The special problem that I have?
What special problem?
It's an induction one, and it's a nice problem.
Okay.
And it'll make you happy.
Okay.
Okay, so,
That remains to be seen. Wait, oh, so that's the one you wanted to do?
yeah.
Okay, then you guys do that one, or you want me to do it?
No, they can do it, they can
Number 16.
We like challenge.
do it. Yeah,
Okay, Yoshida,
Honey
you have the
star.
floor then.
okay, this one's not that hard.
Start this.
Okay, this one's
On video?
I've been sad all day, make me happy.
What are you trying to do?
He has a nice induction problem. This is not gonna be over our heads, is it?
No, this one's pretty good.
Okay, you gotta do it on the left side of the board
Okay.
because that's all the video covers.
So n is a positive. Oh, that made me feel bad because it scratched.
What is Z plus?
Positive set of integers.
Then N, then capital N, then
Oh yeah.
capital N is the natural numbers.
Okay. And
What, did they use Z plus?
I think so, but yeah, that's better.
N.
All right, I
N.
guess the-
Usually N.
Okay.
Okay, so then you have like a 2n by 2n chessboard, and you remove one square anywhere.
You see a chessboard?
Yeah,
Checkerboard,
like a checkerboard. Yeah. And you remove one square
at random.
at like any one of them. You
Mm-hmm.
can show that the remaining area can be tiled by this shape. So like a little L.
What?
You guys know what
Using
tiled
induction.
means, right? Like you tiling your
Like you
kitchen
can
floor.
you can place all of them in the remaining region here.
So 2 to the N,
2 to n and 2 to the n, and so there's induction involved.
alright. Okay, let's see it.
So
I'm ready to be happy.
in the base case, you just have like 2 1 2 1, and then this one's the removed, and it
So
fits.
obvious then.
And you assume that it works for n equals k, and so you want to show that it works for n equals k plus 1. And then when you get to that is by, so this is what I was talking about earlier. You split the 2n to the k plus 1 into 2n to the k and 2n to the k, little triangle or little square. And you want to show that you can tile the whole thing, removing one of them, knowing that you can tile each one of these, removing one of them. Because you can tile this one if you assume that, right? If you remove one. But how can you do that? You can't remove 4, because then you'd be removing more than one. Right?
Okay,
So-
we're removing one.
We're trying to remove one and show that because
So you gotta make cases then?
because you remove one of them from one of these little rectangles, it works. So what you do is you make a little one of these in the middle, and because you know that this region right here can be tiled.
If
right?
you remove one.
If you remove one, because that's the one removed, it works. This region works. This
Mhm.
region works. That works because that itself is the shape. And this one, that's where you take the one out.
Okay, then that makes sense.
Yeah, and then you can show that it works for all. So yeah, it just looks nice because you can do this works, this works, this works, this. They all work together, and this is the only one you have to actually remove.
Oh, how would somebody think of that just on their own?
I don't. It looks nice.
I saw that with ALPS.
Yeah. And there's other ones that are like really hard.
Yeah, I can
But this one's cool. Yeah.
Suppose you have a pentagon.
I love a very interesting problem that's similar to 16 and 17, but.
Okay, what is it?
7.
That was from your summer school class.
Mm.
Okay, let's see it.
I demand some more.
7 divides 5 to the 2n plus 1 plus 2 to the 2n plus 1 for all n greater than or equal to 1.
Hey, wait a minute.
This is
What, you saw the test?
No, this is.
Oh shoot!
Okay, well, no, you take us through it then, since you wrote it.
Let's
So,
see if we
Okay,
can
wait,
do
I'll
this.
do the one case. 7 divides 5 cubed. Is it 2n plus 1 or 2n minus 1?
Plus 1.
No, they're both plus 1.
Oh, you use induction, right? No.
Yeah.
Oh, okay. Then they
Okay, 5 cubed plus 2 cubed.
Oh, then you
128.
simplify.
And
No,
7.
132. No, 133.
Equals
Oh yeah, divides by
133, yeah, 7 goes into that.
Yes.
Check!
K plus 1.
to
equal to 7
j
j for some
some integer.
some integer j.
Okay,
Mm.
and then
P k plus 1 is 5 to the 2 k plus 1 plus 1 so 2k
2k plus 3.
Plus 2 to the 2k plus 3 equals 7
Times parentheses.
and parentheses.
That's to
And
be determined.
yes. And that's like 5 to the 2k plus 1 times 5
Squared.
plus 2 to the 2k plus 1 times 2 squared. And that number is
100.
How can that be
wait, hold on. No, you don't multiply. I forgot how to do it actually. Wait a second.
25 plus 4. Nah.
Well, I know a solution to this that doesn't require induction, binomial theorem.
That's the
It says
binomial
induction,
theorem.
it can cancel.
But binomial theorem, you do it in one swoop. So if you do binomial theorem, you can write binomial theorem as the sum of that and all the other terms. And wait, I'll write it out. But that's cool. You can, but you would also have to.
This looks like something like you gotta add and subtract something.
I think so.
I mean, that's what I feel.
You add 33 both sides.
No,
Each
like
time it-
the first step. If you add or subtract
Something.
like 5 to the something, and then rearrange the terms, you know what I mean? And then you can like factor by grouping somehow.
Somehow.
Oh,
That's
this
the
is
binomial
hard. I
theorem.
think this works.
The binomial theorem?
Yeah, this divides 7. And if you want to show that that divides 7, you just show that all the other terms divide 7. And you do that because each term has some power of oh wait. Does that work?
It's a power and a factorial.
It has some sort of 7. Each term has like a 7 in it. Because like if you were to do this for the case of 3, then you would just get like 5q plus 3, I don't know,
5
5
squared,
squared
2.
plus 3, 2.
2.
Oh, sorry, 3
3
squared,
5 squared 2
2 squared, 5 plus 2
cube.
2 cubed. And this term will have, I don't know, you have to show that this term is also divisible by 7. But I don't know how you do that.
You guys.
I don't
Three.
understand what I did.
Okay, let me look.
I really don't understand.
5.
You typed this out too?
Yeah. It's really gross.
Oh, so look, they added this thing here.
I've always do the homework problems. Hey guys, we're gonna prove prove by induction.
Your hair.
What did you use to type this out?
Latex.
Yeah, a lot of people use that.
Carnegie Mellon, they all use it.
And you can just access it through Word.
Wait, 1, 3, 4, 5, 1, 4, 6, 4, 1, 1, 5,
Where did I go
5,
from
1.
here to here?
I'll do start off with P1.
So you added,
So you say
Yeah,
wait,
if you plug in 1, you
What
say
happened to
3
the-
divides by 3.
2.
Check.
What happened to the 2 to the power?
2 to the that power. It's just like
Plus 1.
Oh, I'm going, okay, where
Yeah.
did this come from?
Plus 1.
Okay.
But then I don't get what I did after.
Then you split up the 25 into 21 plus 4.
Equals
That's what you
2.
did.
3k.
Yeah, that's what you did.
Oh.
You split the 25 into 25 plus 4 and
because
distributed.
because we know that that's divisible by 7, or we assume that that's divisible
Yeah.
by 7. But 21 also goes into
Yeah, 7.
That's why.
Okay, there, down, okay, finish. Okay, everybody sit back down again.
Figure it out. Maybe. So.
Yeah, you can erase my thing.
No, it's fine.
It's my lectures.
So actually, you know what to do, just do it from do it from the top, don't go backwards, go from the top. What was we added,
So
no, I forgot already.
So
See, that's what happens when you get old, I was just looking at it and I forgot.
It's 5 to the 2k plus 3 plus 2 to the 2k plus 3 equals 7 something. So that's 25 times 5 2k plus 1 plus 2, no, 4 times 2 2k
Plus
plus
1.
1. And so I split up into like 21 plus 4, 5 to the 2k plus 1 plus 4 2 to the
Oh, it's starting to take shape.
plus 1. And then
You're not playing games, that's all.
4
Because the video camera is showing you.
5 2k plus 1 plus 2 to the 2k plus 1.
Times 20.
Plus 21 times.
21 times 5 to the 2k plus 1. And since this thing, we assume that P2
It's divisible by 7.
is divisible by 7, then we also have 21 here, which is
That's definitely divisible by 7.
divisible by 7, that's why this whole thing is divisible.
Oh,
Oh, that's nice.
that's tricky. See, that's the kind you get in summer programs.
Oh, no.
It's just guess and check and divide it into 21.
Yeah, yeah.
Guess and check.
Yeah,
That's not guess and check.
21 plus 4 is.
Okay, anyway, I decided we're not gonna have a test on Wednesday.
Because we can't.
No,
When?
if we have it, it's gonna be when we come back,
Okay.
but not the first day.
On the first day.
Oh, yeah, that's.
Well, it would have to be the third day then, wouldn't it?
Wait, when we
Because we come back, isn't it basic?
E day.
Oh, it's
E day, F day, basic.
Oh, EF basic.
EF basic.
Whoa.
Okay, basic then.
Oh no.
Short,
That's
okay,
nice.
let's make it a short quiz then.
A short quiz.
Find the last 2 digits
Of
of,
I. I'll read 2.
of 89 to the, 89 to the 98th power.
My grade.
Okay.
What?
666 to the 666 power.
That's demonic, Mr. Park. I forgot how to do it already.
That is a nice.
Yeah.
Okay, let's post this.
666 to the
Go on,
666.
It feels like there should be a
Alright,
connection.
my class.